A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I welcome you all in today's our online session. Hope you all are fine and having good health. We start today's session. In previous session, we was discussed about the concept of force mechanics, applied mechanics, and its application in applied physics. These are the basic concepts we discussed in our previous session. So force system, equilibrium, free body diagram, and the concept of force in free body diagram we discussed. Afterwards, today's the topic is on law of superposition of forces. So we are start this session today. It states that the action of a given system of forces on a rigid body will remain same even if we add or subtract from them another system of forces in equilibrium. Principle of transferability of forces, it states that the point of application of a force may be changed to any other point along the line of action of the force without any change in the external effect of produced by the force. So this is all about the superposition law of force in mechanics as well as in applied physics. So this is the concept that both the two trucks and body we can say are act if in this position. So if it's moved from left to right direction, then their weight force acting on a downward direction and their resultant or reflection force and reaction force act on bottom to top direction. So these two forces are balanced to each other. But if this force of engine applied on the forward direction from left to right, then this due to the increasing of this force, this body is moving in right direction. In the same aspect, if implement as well as here. So this side of right side figure, you can see that if a force direction, if the forces act on the direction from left to right, then we can say the body is moving in this direction. Same way in the bottom figure of the middle one, if we applied for in this direction, it will be moving in this way. And third figure, we can see that this body would be in equilibrium if all the forces act on the body cancel out each of one its effect, then it will be in static position in this same way in this way. After that, coming towards the law of mechanics, which are the Newton's first law. It states that every body continues in its state of rest of uniform motion in a straight line unless it is compiled by an external agency acting on it. Another way we can say this first law of Newton's mechanics law that every body in the universe continue in its state of rest or motion until and unless any external force cannot act on it. So this is all about the Newton's first law of motion and Newton's after the law of mechanics. Now coming towards the second law of Newton's that states that the rate of change of momentum of a body is directly proportional to the impressed force and it takes place in the direction of the force acting on it. We can say that the force is directly proportional to its mass and then multiply by the acceleration. So we all know that the formula derived from this concept is F is equal to ma. Now coming back to the third law of Newton as well as the motion, it states that every body action there is an equal and opposite reaction. So if we produce some kind of action, the reaction would be occur in opposite direction by the body. So another concept in mechanics, applied mechanics, is Lemmy's theorem of law of sines. Lemmy's theorem states that if three coplanar forces, coplanar which are forces in same plane, many kind of forces act on it. So this plane is called the continuous in same state of plane is called the coplanar. Acting on a point R in equilibrium, then each force is proportional to the sine of the angle between the other forces. So this is the Lamè's law of sine and sine law. Parallelogram law of forces. Parallelogram law of forces state that if two forces acting on a simultaneously in a particle are presented in magnitude and direction by the two adjacent sides of parallelogram, then their resultant is represented in magnitude and direction by the diagonal of parallelogram passing through their point of intersection. Triangle law of forces are Triangle law of forces states that if two forces acting simultaneously on a particle are represented in magnitude and direction by the two sides of triangle taken in order, then their resultant is represented in magnitude and direction by the third side of a triangle taken in opposite order. So this is the all about triangle law of forces. So we are discussing in thorough way the force, its concepts, its effects, and the implementation of forces in applied mechanics, which are the representation of applied physics state of branch. So coming towards the resulted of number of coplanar concurrent forces by Polygon law of forces. Polygon law of forces is applied for finding the resultant of a number of coplanar forces acting at a point. It is a graphical method. It states that if a number of forces acting simultaneously on a particle are represented in magnitude and direction by the side of polygon taken in order, then their resultant is represented in magnitude and direction by the closing side of polygon taken in opposite order. So this is the resultant number of coplanar concurrent forces by the Polygon law of forces. Now this is the most important aspect in mechanics, that is the coordinate system. So it is a system designed to establish position with respect to given reference points. The coordinate system consists of one or more reference points. The style of measurement, linear or regular, from those reference points and directions or axes in which those measurements will be taken. So this is the dimension of three main axes with the respective of negative, including the negative axes become the 6 axes, in which positive x-axis, negative x-axis, positive y-axis, negative y-axis, positive z-axis, and negative z-axis. In satellite navigation, various coordinate reference systems are used to precisely define the satellite and user location. So classification according to the body reference and location of origin, a coordinate system may be topocentric, that used to observe observers location at the center. Geocentric means the origin earth mass center. Heliocentric means origin the sun. Selenocentric means origin, the moon. So these are the coordinate systems and in their classification. Depending on the way of depending on the way the coordinate system set, it may be polar, cylindrical, spherical, and Cartesian. So these are the some of coordinate systems which are exist in nature. So polar systems are those in which their magnitude and angle mentioned. So these coordinate system are mainly depend upon the two things: their magnitude and angle of direction. Second category is the cylindrical, in which the radial length, height, and their angle is mandatory to mention it. Spherical means the radial length with theta and phi angle are represented there. And the last one was the Cartesian, which is the most important basic concept in coordinate system geometry, which are axes are x-axis, y-axis, and z-axis respectively, which are also be mentioned here that x-axis, y-axis, and z-axis in this shape. Topocentric and geocentric are most common use for purposes of satellite navigation system, which are mentioned in the top para. So coming towards the detail about coordinate system, which are the number one is polar coordinate system. And I'm also discussed and covered the concept that the direction and magnitude is important for polar coordinate system in the respective of its magnitude and angle. Cylindrical coordinate system, you can see that its radial length, its angle of making, and the height of z. We need to represent this coordinate system that we call the cylindrical coordinate system. Further, the spherical coordinate, coming back towards the spherical coordinate system, to represent this system, we need its radial length, theta and phi, both two angles to represent the spherical coordinate system. Now further, the last coordinate system in applied mechanics are we called a coordinate system Cartesian. Another was named it a rectangular coordinate system. In Cartesian coordinate system, it depends upon mainly three axes and their three opposite axes as well. The x-axis, y-axis, and z-axis, length, breadth, height of a particular object of body represent in this origination of axes, and we are very well known in it in our basic and primary classes to discuss the concept of graphical representation of 2D and 3D in linear graphs which are made on the axis of x, y, and z axis respectively with their negative axes as well. So geographical coordinate system, you can see that the geographical coordinate system enables very location on earth, every location of earth to be specified in three coordinates: latitude, longitude, and height. It based on a spherical coordinate system, and spherical coordinate system is depends upon the three quantities which are the its radial length r and its uh, theta and phi based angles. So which are the latitude and longitude, and the height was its radial length. Inertial and non-inertial reference system. So an inertial reference system is the coordinate system in which Newton's law of motion are valid. Inertial reference frame are neither rotating nor accelerating. And another one, a non-inertial reference system is the system that undergoing acceleration with respect to an inertial system. So this is all about today's session. Hope you understand these concepts. If you have any kind of question, query, or difficulty regarding today's session, please feel free to ask. I will answer the kind of question and resolve your queries if you have in your mind. So if you have any kind of question or query regarding previous session, please feel free to ask. I will answer and resolve your queries regarding the previous session of applied physics. So this is lecture number 30 and 32, in which we discuss the application of applied physics, coordinate system, implementation of forces, and how the quantities and the physical aspects are relevant with the coordinate system, which are the polar, rectangular, Cartesian, cylindrical, and spherical systems of unit, on which we can represent the basic quantities of applied mechanics, of applied physics. So this is all about today's session. Inshallah, we will meet by the next new topic of applied physics. Up till now, Allah Hafiz.